needs time. It's a very good problem where you have to put effort. Meanwhile, let me have water. Okay, the terminals which are there, you can give some name, A, B, where the wire is connected. Let me call that as X, Y. We can have a situation of like this also. There is a possibility. If you can recollect, no, I often use the word redrawing circuit, the circuit which is appearing like this. No, if you can convert into some other shape, the problem becomes very, very, very simple. Or else, no, sir, I'll manage. How many loops are there? 1, 2, 3, 4. 4 loops are there. Nothing is working out. 4 loops are there. Apply the loop current. KVL means here one I1, I2, I3, I4. Solve it. 4 equations, 4 unknown. That's the last option. Or else what happened? You have to redraw the circuit. How to redraw the circuit? Look at the points which are at same potential. X and Y are at same potential. So rearrange the circuit, redraw the circuit. Student has to apply method. There's no other way. You have to try. The current LCT chapter will come with such a flavor. No, I can ask you questions where it will trouble you a lot. You have to think. There's no other way. See, you know concept. But here what happened, concept is other side. It's about the methods. How students will think in a different way. There's no any hard and fast rule. That's what I'm saying. To solve a problem, the basic Ohm's law, KCL, KVL. Applicable in almost every problem. But the as how to proceed here is what you have to work out for the skills. These two are at same potential. Okay, this is AB. Don't disturb AB. Okay, I'll proceed in this way. I'll proceed in this way. This is AB. See, even for everyone, even for me also, first time, as I had to struggle a lot. This you keep in mind. Okay, this is a point X, don't disturb. So this is X and this is the point B. Have it here. This is 2 ohm. Okay, we are not going to disturb it. No, between X and B, we have 4 volt. Let it be as it is. No, look at this branch. Okay, here you're going to bring 2 ohm and 8 volt. This you write it B for your convenient. Later on we'll simplify this one. Now look at this 8 ohm. Okay, this is 8 volt. This is 8 volt. 8 plus 8 again they are in series. No? So 16 volt and 2 ohm. Where it is connected between A and Y. X and Y are at same potential. X and Y are at same potential. Okay, there's a common point B we made it. Again B and between Y. So between B and Y, so here one cell will come. Okay, this cell, nothing but these two, this will be parallel to this. Okay, this is X, no? So yeah, well, I think I need some space. X and Y are common potential, so I'll introduce Y here now. I'll call this as Y. Between B and Y, this particular thing, between B and Y. So B is here. The X and Y are common, they're connected by Y. So between B and Y, we'll connect here. So this one, so one, this will be 2 ohm. Four volt. Okay, I think maximum over. Okay, now between A and Y, you have to bring one resistor. This cell between A and okay, this Y or nothing but X, both are same, no? So here we are going to bring from A to 8 volt. Anybody can redraw. What is their drawing class in schools? You were asked to draw. No, why we were asked to draw for this part was only here. Connected to X or Y. Okay, connected to Y. Okay, you'll get confused. Okay, sir, you're connected to this one. You see this. I will just for your help. I'll put like this. Conducting wire, no, X and Y. So that will show it here. This is our resistor. There's a point B. There's everything is point B. Okay, let's further simplify this. Okay, this is 8 volt, 16, and this is 2 ohm. And now you can ask questions, sir, how do I come to know I should think like this? This is what you have to analyze. So whenever you get a conducting wire, what is the best thing? Make X and Y common. Okay, next part, I think I can, I'm in very good position. So look at this, 8 ohm, 8 volt, 2 ohm, 2 volt, 4 volt, 2 ohm, 4 volt. I think there's a grouping of cells. Shall I apply for this? Anybody can you directly tell me the answer? What is that XB? The grouping of cells. Okay, we'll do one thing. So like how do I come to know? Okay, I'll apply the formula. Okay, we'll apply the formula. First, we'll go for Vx equal to Vy. Vx equal to Vy. So therefore, EXB will find out grouping of cells. EXB should be equal to summation of E by R. Summation of E by R will be 4 volt. EXB, no? So we'll take X as negative, B as EBX will find out. So EBX will be 4 summation of E by R. Here 0 we are having. What to do now? The resistance here is 0. Somebody said something. What is our formula? Summation of E by R by summation of 1 by R. What is the effective resistance across this is 0. Then this will be minus 8 by 2. This will be plus 4 by 2. Summation of, again, will end up with summation of 1 by R. 1 by 2 plus 1 by 2. I think this is not defined, no? So this particular formula will not help us. Then formula will not help us means what to do. You go back to the cell. What is the cell? Now the idea of cell will come. What are the conditions in the external circuit? The potential difference is equal to your 4 volt. Finish over. We got it. And what is effective resistance? We'll calculate effective resistance. We'll see what do we get further. Summation of 1 by 0 plus 1 by 2 plus 1 by 2. This will be infinity. 1 by 2, 1 by 2. This will be 1. This will be 0. So therefore, EBX, what shall I write? EBX, I should write equal to 4 volt. But you said, sir, it's undefined. It's from this formula undefined. I'll get it. How much it will read potential difference? 4 volt. What is the effective resistance? 0. So there's all these 3 cells. I should just with only this 4 volt only. I think the problem has become very, very, very simple. I think you should make observation. There's no other way. Even for you, me, anybody, what happens should think, analyze here. Okay, then, so if I replace them, okay, this will be 16 volt. There's a 2 ohm, there's a 0.x, there's everything. This is the 2 ohm. This is 1 ohm. We have to calculate current to 1 ohm, no? So there's everything here, how much it has come. It has just ended up with 4 volt. X comma Y, and this is the point B. Now the problem is a little bit very simple. We can easily work out here now. This current through this 1 ohm has to be determined. Okay, don't go for further grouping of cells. Just leave it, and there is a 2 loop problem. Okay, here we'll assume one current I1. This will be I2 plus minus plus minus plus minus plus minus. Let's write loop equation and solve for I1 and I2. We'll get the expression for current through the resistor 1 ohm. (16) minus 2I1 plus 2I1 minus 2I1 equals 0. So 16 minus 4I1, this is 2I2. 4I1 plus 2I2 equals 0. Similarly, plus 4 minus I2 plus 2I2 minus 2I1 equals 0. So 4 minus 4 plus 3I2 minus 2I1 equals 0. Solving 1 and 2, then we'll get expression for current I2. So I will just take some symbol yellow, green, all we use. No? This is everything. I'm just replacing with equivalent. Anybody solve I1 and I2? Give me the answer. What is the EMF? What is the EMF of, what is the potential difference across these points? 4 volt. What is the effective resistance? 0 ohm. So I should replace this point XB, which should be equivalent 4 volt only. So what is a cell? Okay, the main idea is the idea of cell has to be, student has to develop the idea of cell. If this is E, this is R. What is the cell? The EMF of cell will be constant. What cell will do? Though you vary the resistance R, current will change. The EMF of cell will be constant. There's a property of a cell. So it's like a constant voltage. Current through it can vary, but the EMF will remain constant. That's what a cell is. So what is the basic idea of a cell? Constant voltage, EMF is what we are deciding. So the current through a cell can vary, but the EMF of a cell will remain constant. Just potential difference, go for electrostatics. What is the potential difference between these 2 points? 4 volt. 4 volt. But sir, these are there. In spite of that, what the effective potential difference here will be 4 volt only. Because here potential difference Vx equal to Vx, Vy. Vyb should be equal to Vxb. So what is the potential of 4 volt? So whatever be the EMF and cell resistance here, the effective potential difference or EMF will be 4 volt only. Anybody value I2? Value of I2? Anybody value of I2? Solve 1 and 2. You multiply this equation with 2, this will be 4, and then subtract.
Two ampere, sir.
2 ampere. I2 2, I1 5. I2 2 ampere. Okay, this will be our answer. Okay, we'll start the maximum power transfer term. At least theory I'll finish off today.